helping you with Acorn and RISCOS computing.
Right, okay, well, we'll make a start. Managed to get we've used all the wires anyway, so if nothing else, some electrons are going somewhere. So, right, thank you very much for having me. I realised I think it's been maybe 3 years since I was last here. 2019 was the previous set of PowerPoint slides I could find, where I came and did some PIC traffic lights on a PIC micro I remember doing. So there is a little bit of PIC micros in this because that's one of my personal pet projects. So the theme that I managed to stitch together for this, I think, is one of speech synthesis, if you've got your teeth in. So starting from the BBC Micro, which very generously been lent to me to save me bringing it in my rucksack, and through to how you can do speech synthesis on RISC-OS, and then how that's integrated into Texties. Got one wire less. Is that an important wire?
Can you zoom in on the screen, Ruth, please? Can you zoom in on the screen so we can see what's on the screen?
We're having trouble with the wires.
Somebody's been plaiting me wires.
You're on in a minute.
Have we got the direct feed out from the computer?
Yeah. Don't like it.
Doesn't like it, does it? Right. Let's try plan B. Only want to sit down on that.
That's guaranteed.
Let's try to look at this room.
It's on manual. Use the green. Going old school.
Point the camera at the telly.
Yeah. Lock it off at that.
Yeah.
All sorted, yeah?
Yes.
Yeah. Okay. There is going to be some sound in a second, so from the computer. Yeah. Yes, and then as I mentioned moments ago, finishing off with looking at Texties Studio. So I thought, as there's no football on tonight, we should have some other up-to-date news.
The nation pays its final tribute to Earl Mountbatten of Burma, victim of the IRA. His funeral service at Westminster Abbey was attended by the whole royal family and leaders from many parts of the world. One of them, the Irish Prime Minister, Mr. Lynch, later had talks with Mrs. Thatcher, and they agreed on the need for greater cooperation on security. And tonight's other major stories. In Blackpool, the Trades Union Congress have rejected a call for mass protests at the government's economic policies. The American Secretary of State has asked for urgent talks with Moscow about Soviet combat troops in Cuba. And the British business...
Yeah, you're exactly right. When I found this is a clip from 1979, I thought, oh, so we've had a state funeral. There's friction between the trades unions over pay. Russia and America are logging horns over occupied land. And what was the news story there? Yeah. There were 4 news stories, and I thought all of those could just be from today. Oh, it was, friction at the Irish border. Yeah. So anyway. The news articles themselves weren't that important. It's that the news reader is Kenneth Kendall. So he was a BBC news reader. That was from 1979, and he retired from the BBC News in the early 80s, 1982. So why is that important? So starting off with my theme of speech synthesis. So the TMS 5220, which somewhere in one of my piles, there we go. I did actually manage to squeeze the data sheet for this out of Texas Instruments in the time when data sheets were actually printed on paper. Hand that round for true old school data sheets before things came in PDFs. So the speech synthesis chip, and this is why we've got the BBC Micro here, is actually a really pretty cunning bit of silicon. So what it does is it has a 12-tap model of the human vocal tract. So when it's playing back samples, it's not doing as you might do on a modern computer where you just store the raw samples in memory, play them back at 44 kilohertz, and that generates music and sound. What they've done is whenever you have some speech, as long as you're encoding speech, you can look at which bits, if you imagine it like a guitar with 12 strings, your throat, which of those strings would I twang in order to make that sound? So it gives really, really good compression of speech, because rather than storing all of the raw samples and playing them back at the sampling rate, what you're actually doing is you're just storing a lookup table of values which correspond to what your throat would have done. And this is very similar way of thinking to how MP3 works. So when you compress audio using MP3, what it's doing is you do a Fourier transform of it, and then you look, well, if these two frequencies are really loud, then your ear won't be able to hear these upper two. So we can just throw those away and you won't notice. It'll still sound the same. And that's how the compression for MP3 works. And for this, it's got a model of the human throat. And that's how the compression here using linear predictive coding works, is you only bother storing the things that you would have twanged in your throat in some special chips called phrase ROMs. And there's highlighting here because phrase ROM gets squashed down to from. So if you ever see things referencing BBC micros, you'll know that that's what a from is. If you're into electronics, just down at the bottom of the screen, it's truly quite a weird chip. I do have one of the chips here as well. Let's have that round. It's less exciting. It's just a 28 pin generic black chip. It's weird electronics in that it's PMOS. It's the only chip I've ever seen that uses PMOS. So you've probably heard of CMOS electronics. So often yes, it's bounced on the floor. The electronics that's in your mobile phone is all CMOS, low power CMOS technology. So it's complementary metal oxide silicon. And then in the early 80s, most things were NMOS. So the processor, for example, in the BBC Micro is an NMOS processor. And the way that works is there's a transistor at the bottom, which is called an N-type transistor, and there's a P at the top. So the processor most people typically use the ones where it was only the bottom transistor there. For some weird reason, the speech chip uses PMOS, so everything is backwards. So it runs off a -5 volt power supply rather than a +5 volt power supply, which is very mind melting when you're looking at the schematic. Everything is upside down. And the FROMs themselves, you might have thought, oh, they come in an 8-bit EPROM. No, that would have been too easy. They come in some weird 4-bit wide serial FROM. Again, no one really knows why. And if you recognize the item on the right there, that's a Speak and Spell, which was another product from Texas Instruments, sold mainly in the US, not so much in the UK, where you could enter words on the keypad and it would then speak them back to you if you're first learning to read and write at primary school. So the BBC Micro angle, yes, I heard someone mentioning about the famous ashtray on the left-hand side of the keyboard. So yeah, when the BBC Micro was being designed, there were no speech chips available at that time. So what they did is they left rudimentary support in the operating system for a speech system, even though they didn't yet have the chips. So they left just enough support in because they knew that they needed to ship the computer anyway. And I thought, well, we'll just worry about fitting it all later. So there's simple support in BBC Basic through the sound command. The cassette filing system, you can access the speech from as though it were a cassette file, even though it's not a cassette, obviously. So you could store data files on the from as well and read them back. And the idea for that really was that they were going to store games. You'd be able to buy games stored in speech FROMs and then plugged in temporarily into the cartridge on the left-hand side of the keyboard. Right, another quick interlude into where Kenneth Kendall is in his career.
Hello, and welcome to another edition of Treasure Hunt. Our two contestants this week are Terry Hickman and John Willis, and they have, as usual, got 45 minutes in which to try to solve a series.
I can't decide whether that was a downward slope in his career or an upward slope. So he's gone from reading the headline news on the BBC, and now he's helping Annika Rice flying around in a helicopter in various bits of Berkshire. I think this episode was from. So yeah, that was what he was doing in 1984. But in between, Acorn managed to get him to do some recordings, which was what they then used in the from provided with the BBC Micro. So what he did, because you are ultimately limited by the amount of memory available in these chips to 16 kilobytes. So what they actually did was to create just a list of word parts. And then you can stitch those word parts back together again to form complete words. So the easiest example I could think of is there's for and T. And if you play those two immediately after each other, obviously it says the word for T. So I did bring a printout, apologies for it being on pink paper, of all of the word parts. So there's a surprisingly large number of words because even though it's only 16 kilobytes of memory, there are still a lot of word parts because of the compression that the speech chip can do. So, slight downside to this, as we mentioned with the ashtray, is that actually this didn't sell very well at all. It was outrageously expensive for what it was, and you only got 16K of storage back in return. So Acorn didn't do any subsequent production runs. So what you actually find if you look on places like eBay, for example, is that there are many spare TMS 5220 chips because these were very common from the Speak and Spell and other products that use them. So that was the generic of the two chips, and the custom one, which I did also bring the data sheet for that. If anyone excited by looking through data, it's still got my handwritten notes on it from when I was trying to work out what the chip does. But there were very few of those made. And so I thought, well, hang on, why can't I just make one of these chips by emulating the chip with a processor that's running fast enough to be able to feed the data into the vocoder chip. And that when I first thought of the idea wasn't actually practical. What you need is 160 kilohertz playback clock. And that doesn't sound too fast, but when you think about it, if your processor that you're simulating this chip on is running at, say, 2 megahertz, then you actually only get a few clock cycles per byte that you need to deliver. And when I tried to work out whether that was possible, I couldn't find any chips that were small enough, fast enough, had enough memory to be able to do that. So I kind of parked the idea. I had the idea sometime in the 1990s, and I had to park it. But by the time we get to the early 2000s, suddenly I noticed that there was a new family of PIC micros available, which are the PIC 18 family. So that started to tick off some of my requirements. So yes, there's 16K of memory, so that's enough memory to store all of my samples. That's good. There's a bit of overhead to store the software in. And finally, we got one that ran at 40 megahertz. So it ran fast enough. If you work that out, 1 over 40 million with a 4 blocks per instruction cycle, which the PIC has, works out at 100 nanoseconds per operation. So you can actually now get a fast enough processor with enough memory on it that you can simulate the whole thing. So there's a bit of background information on how that differs from the PIC 12 and the PIC 16, which are the kind of the smaller brothers of the PIC 18 family. It's not desperately important, but the bit that I needed for what we want to do with the speech encoder chip is the very last line there is that the PIC Micro is a true Harvard architecture microcontroller. So the program memory can't read itself. So the instruction bus where the instructions go past and the data bus where the data is going past are two separate buses and they can't talk to each other. So if you wanted to be able to return return 16K of data, that wouldn't be possible until the PIC18 family came along, where they allowed you to read from the program memory. So a lot of moons or a lot of things were all suddenly aligning, making this possible. So that was my cue to start making a printed circuit board, and I have I fitted one into the BBC Micro here. I don't know whether you want to. We could take the top off and have a look in a minute. I don't know whether that's possible after this slide. So the speech, the TMS 5220, read the number sideways there. The TMS 5220 is just an entirely stock Texas Instruments part. And then on the left-hand side is the board that I have made. There's the PIC18 processor, a crystal to run it at 40 megahertz. And then, as I mentioned, it's weird PMOS upside down circuitry. So I had to have a -5 volt regulator to power it off. It's all very confusing when you look at the schematic. I was very pleased, though, when I was looking at the date codes on all the chips here, that actually the disk controller was from 1978, the speech vocoder from 1983, and then the PIC Micro from 2005. So we've got a full, nearly a 30-year span of chips that all just happen to be next to each other in that when I took that photo. So we're programming PICs. I've shown you this before when I was here a while ago. I wrote my own PIC programming tools, which allowed you to write the code in something that looked very much like BBC Basic, except when you open the square brackets to go into the assembler, instead of writing 6502 or ARM assembler, you could write PIC code instead. So other than that, it looked very familiar, which is very handy for me because obviously it then allows you to use normal RISC OS editors. So you can use StrongEd to edit it, and it gives nice syntax coloring and that sort of thing. And then programs via the programmer board, which again is something I showed when I was here last time. It's exactly as in the photo. It's got a ZIF socket for sticking the chip in, and then a Centronics parallel port on the other side. Now, that has caused some problems as technology has advanced, that parallel ports have started to disappear. So when I first started doing this, the RISC PC, obviously that has a parallel port on the motherboard, so I was able to plug my PIC programmer straight into the RISC PC. As newer computers have come along, so the Titanium, which is on the desk beside the monitor here, you can add, using the PCI Express expansion card slots, parallel port there as well. And then again, I think I showed this when I was last here. There's also a hat that you can plug on top of a Raspberry Pi, so that your Raspberry Pi, despite being 20 years newer, or no, 25 years newer than a RISC PC, you can still have a parallel port. So I'm going to throw caution onto the wind at this point and install a parallel PCI card while we're here, because if there's working, don't never work with children, animals, and do live demos. So I'm doing pretty much all of them tonight except the animals. So if I just quickly shut down the computer. And it bring my calibrated screwdriver.
Switches over to the camera feature.
So I did bring a case that has only one locking screw at the back, because otherwise I'll be here all night undoing screws. So inside, titanium motherboard, nothing unusual about that. And if we take the spare blanking plate out the back, I'll leave the top off so that it's visible when I stand it back up again. So that is parallel PCI Express card. So it's got a 1-lane PCI Express on the bottom, and then it's got, because this is a reduced height case, it's got a reduced height back plane as well. That goes in the hole. Managed to not lose the screw. Let's do the right. Sure, my fingers used to be smaller. There we go. Gotcha. Right. So that's for as far as I can see it. Let's turn it back on again. No magic smoke. That's good. Stand it up so it's just enough space on the keyboard. Case is now upside down, which is slightly strange looking, but it's okay. Booted, that's good. Let the HCP to time out. Right, I'm just sneaking and change back to a mode that's not microscopic on this monitor. Mouse, there's mouse, right. 1280 by 800, 720. Yep. So if we go to, I'll go back to the slides in just a second. Upside down. So if we open a task window, which you may not be able to see at that size, if we type PCI devices, so it's now gained a parallel port. Slot number was that in? Slot number 1. Various exciting internal statistics about the PCI socket. Not desperately exciting. And then if we run the parallel device driver module, we can then type cat devices. And now in the list, we've gained, as well as the USB ports, obviously, and there's the 2 serial ports on the motherboard, we've now gained a parallel device as well. So that would be what your, the PIC programmer picks up. Oh, that's a pun, yeah. The PIC programmer picks up the parallel device and sends the data over to the PIC down the printer port. So if we go back to the slides. Where were we up to? Parallel computing, I think. Yes, that looks familiar. So get the buttons the right around. Yes, right. So now we've fitted the parallel card. We can imagine ourselves programming the PIC, and the PIC programs PIC fits inside the BBC Micro. So I'm going to see if this works as well. I love a live demo. Okay, so we did discover unfortunately that through the passage of time, one of the pins on the knob that adjusts the speed of the speech synthesis isn't working, unfortunately. So it's going to play back a little bit slow. But I fitted the TMS 5220 chip, and I fitted the emulator, which is using a PIC micro. Thank you. And I've written a very little program that's going to speak 4 phrases that I had got while I was setting up from here. So number 265. It's going to, yeah. I think I remember what I've set it to say. Oops. Oh, that's the BBC Micro. Oh dear. It's unhappy. The cursor's flashing, but the caps lock will show you. Press break and try and hold. Ah, well, we can do all. Okay. So you have to imagine it was a little bit faster than that. It's supposed to sound like Kenneth Kendall that we've just been watching on the video. So yes, the phrase that I chose was just based on the list of words that I could easily string together in a sentence was "Thank you, Acorn Computer." It definitely does say it, but yeah. Normally it sounds a lot more like Kenneth Kendall. He's obviously been he's just had a cold, and a deep throat, and a sore throat at the moment.
As we convert to adult.
Yeah, thank you. Yes, back to setting. Oh, okay, yeah, sorry, there's a switchy box. I forgot there's a switchy box in the way, yeah. Okay. There we go. Right. Yes, so a couple of other features that I managed to shoehorn in as well, because the PIC Micro is new enough that it's flash based. It's not EPROM based like the memory was in the 80s. It's flash memory based, which means you can reprogram it in the field. And I was looking at, well, it's made it back to me. Yeah, so I was looking through the table of possible opcodes. You look through all the exciting state diagrams in the, or on that camera, there are some exciting state diagrams in the data sheet, and I noticed that there were some unused states. So I was able to repurpose one of the commands to allow you to reflash the from in the field. So if you get fed up of Kenneth Kendall talking to you, you can reflash the from, and I made a from that had various sound bites taken from movies. So What Is Thy Bidding, I think, is from Star Wars. Hasta la Vista is Terminator, I think. One Small Step for Man is Neil Armstrong, and Beer is one of the Simpsons movies. And then just falling off the bottom of the screen there, the other thing that I made was a telephone, what is caller ID? Yeah, a caller ID system for a telephone, so that you can, if you're out, it will record the calls that have come in, and then when you come back in the evening, you just press the space bar on the BBC Micro, and it would speak back the phone numbers to you. Just lost them. Yeah. Right. So moving away from the BBC Micro to something RISC-OS based. There's the eSpeak package from Jonathan Duddington. Often you'll see that demarked by a set of red lips. So there's quite a few applications. Texties has a red lips button. Pluto, it's obviously one of Jonathan Duddington's other applications. And StrongEd also has a button on its toolbar to speak back at you. And it will in fact say any reasonable phrase that you can type. So if I sneakily grab a task window, I should just be able to say, type this one. Oh, hello. Hang on. It's like live demos.
Hello to the Wakefield user group.
Not bad. pretty serviceable. And in many ways, this is running in the same way. There isn't a massive database of megabytes and megabytes of samples on my hard disk, because it's unlikely to have known the word Wakefield. So it's building up phrases from word parts in exactly the same way that the from in the BBC Micro was. You store partial bits of words, and then the rules of English means that you can glue quite a few of them together and try and get the intonation right. So it's very useful for spotting typos. If you've ever tried proofreading something, you'll probably find that your brain automatically corrects written words as you read them, provided the first and last letters in the words are in the right place. So it's great fun writing out sentences like that and seeing if anyone actually notices that you've jumbled up almost all of the letters. Because whenever I'm proofreading, I often get from and form mixed up when I'm writing things, because I know what the sentence is supposed to say. So my brain has auto-corrected it and it looks fine to me. But if you speak it, it's really obvious. If you hear it through your ears, it's really obvious when there's a mistake. Lost the input focus? Yes, lost the input focus. So yeah, Texties is an example of one of these applications which includes speech synthesis. So it's actually, it was originally a program written by Danny and Jeff at Softies, and their philosophy was you shouldn't ever need to look at the manual. It should all be really obvious how to use, and if it's not obvious how to use, something has gone wrong. And one of their main target audiences was school-age children. And they're never going to read a manual, so you really need to be able to just be dragging and dropping in a very intuitive way. So it's actually a suite of 6 applications, which I'll very quickly go through. I know I've talked about this previously. So there's the DTP package, which is the main editor. I guess you would count that. It's kind of a souped up word processor with graphics and things. There's the Paint package, Texties Paint, which allows you to draw line art pictures and apply effects, smudging ink and doing red eye correction on photos, that sort of thing. There's a spreadsheet package which can import data from Excel and then plot fancy pie charts and other things which you can then integrate into your DTP work. So if you're writing a newsletter or something and you want to show sales figures, then you can do the sales figures in the spreadsheet, drag the pie charts into your article. And then just falling off the bottom of the screen, there's also the Turtle and the Branch packages, which are actually more educational themed. So the Turtle is an implementation of Logo programming language. So you can say, go forwards 10, turn right, and it will draw you a picture based on your commands. And the Branch package is for doing what you would count as a classification database. So if you said, is it a fruit? Yes, no. Does it have pips? Yes, no. Oh, it's an apple. It's that kind of relational database. So yeah, the DTP package is kind of the central part of it, where you can enter text and simple graphics. Also do OLE editing of sprite and draw files. So if you've got diagrams that you want to insert, they can be drag and dropped in and then OLE edited in place. It also has a spell checker built in with it's about 40,000 word English dictionary, and can print out its output up to 9 meters by 9 meters. That's the largest paper size it understands. So if you're trying to make a collage to cover an entire wall, in principle, you can do that in Texties. So yeah, as I mentioned, the graphics all kind of, all of the packages are all very similar, that you can drag each thing between each element. So if you've drawn, if you've drawn a pie chart in the spreadsheet, you can drag that into the DTP. If you've got some graphics or an animation, you can drag that in. So that you are watching this done in Texties, and there's no magic about that bunny rabbit that's walking. It's just an animated GIF that I have dragged straight into it. So there's no special properties of that bunny rabbit walking. It's all just part of the package. And then there's also you have a data bank full of pictures. So if you've got frequently used clip art, you can store those in a collection. Painting package, is, as I mentioned, in fact, if I swap to the mouse and you can literally scribble on top of things as you are going. And that's treated as though it's just a painting page now. So even though it's a presentation I'm showing you, I can scribble on it using the painting tools. TextEase table here, as I mentioned, you can import from CSV and Excel. Yeah, CSV and Excel. And again, these are live. I hover the mouse over that. The carry will let it. This is live. Oops. Live. Go backwards. Right. Click there. Yeah. If I hover over that, this is a live spreadsheet buried inside the presentation. So all of the equations here are calculated live. If I was to update that, if I was to stop the presentation, edit it, it would recalculate that on the fly. And TextEase Presenter is obviously the thing that I'm using to do this presentation here. It's great for doing things via Zoom or in person, and the full screen mode, which is what we're using here on the screen. You can leave it automatically running through, so you don't have to attend it. If you just want to leave it on a carousel in a shop window or something like that, then you can leave it running unattended and it will automatically advance the slides. And you can have obviously animation. I've turned the animations off here because I find them a bit cheesy myself, but you could have things appearing and the text flying in from the right-hand side of the screen. And it's very nearly 6. And I don't mean that in the birthday cake sense that it's 6 years old. I think it's more older than that. It's more like 20 years old. But it's very nearly at version 6. So I'm canvassing for any ideas for people that want to add things to TextEase. Now is a great time before, well, we're still at version 5.99. So a few features that I have been adding is there's now, if you don't have one of these laser pointers that shines a laser out of the front, I'll put my hand over it, yeah, shines a laser out of the front. There is now a pen style that looks like a laser pointer that you can use on the screen directly. There's also some improvements to the HTML exports, because the way that it used to export pages is they would embed JavaScript, and if you try and run those on a modern browser, the JavaScript says, oh, you're not really allowed to update that page, because the way that things like a presentation would be exported is you would have a bottom bar done in JavaScript, and then it would be updating the frame that had the pages in. But you can't do that anymore in modern web browsers. So I've had to modify the way that the HTML works. A few internal gubbins to do with the compression library. So zlib is a compression library that's used internally. And I was using it earlier. There's now wireless clicker support, so you can do that and switch. You can blank the screen, unblank the screen. And it turns out these are actually fairly common, because our good friends at Microsoft with PowerPoint has commonized the key presses that are used by all of the zappers. So pretty much any zapper you find, as long as it says that it works with PowerPoint, it will now work with TextEase as well. So yeah, there's a few different bundles of TextEase available. TextEase Home is the entry-level one that's just got DTP and Paint. Then if you add the Turtle and Branch, which I said were educational themed, that becomes the educational version of TextEase. And then the professional version of TextEase has all of those things, all of the things from Home, and then also the spreadsheets and the presenter packages in as well. So I've run out of slides and the battery hasn't run out on the clicker, so I think we've done fairly well. Are there any questions from anybody?
Any questions?
The slide, Rob, where you did the painting on top of the text, could that be saved out? If it was
Yes, so it is actually. If I go back to that in the thumbnail view, you'll see that my scribbling is part of.
right.
Probably too small to see from over there, but if I make it
Just about, yes.
So the things that I was scribbling in the presentation are now part of the presentation. So if I save that, yes, my scribblings also get saved. Yes.
Yes, that's useful for like questions from the audience, things that have been highlighted during that presentation. And if you do a save as whatever version
or
B.
if you were printing them out to hand them out at the end, then the things that you've been emphasising are more obvious. Yeah.
Yeah. Anybody else for anything else? No, we've got. I've look at the chat, won't we, Ruth, as well? See if there's anything in the chatties.
Yeah.
I'll have a look at the chatties then. So no, let's see.
I do remember.
I think there've been some questions and we've been going along, so we might catch up on those.
Do you remember, Peter, that you had suggested adding presentation timing?
That's right. Yeah.
I remembered your name. I was hoping to have it. I was hoping to have it for tonight to be able to show it off to you because I thought you might be here.
That's right.
But unfortunately, I was out most of last week and ran out of time.
That's okay. We'll let you off with that. We're just having a look through the chatties, seeing
Yep.
the things that we can speak, or things that we shouldn't speak.
Yeah.
Cameraman, yeah, I've seen that one somewhere. Yeah. I think we're talking about wobbles, aren't we? Let's have a look. Question was, let's have a look. Presentation of the risk cost. Does it understand artworks files? Can you put an artworks file in a text-ease presentation?
Not what I know of. No, you would need to convert that.
You'd have to export.
Yeah.
Right, export as draw or something like that. Okay. I still don't know the answer. Will cats chase the fake laser pointer?
Yeah.
It's the good one. Let's have a look.
Could have fake pointer with animated cat mode. I like that.
No, trick question here, because this is, I think, is a risk-os question. Presenter console and multi-screen support. Now, this is if you're doing a professional PowerPoint.
Right.
I used to work at Leeds and do a lot of stuff helping people with their PowerPoints. And of course, have presenter view, where they're seeing their notes on one screen somehow, and then the actual presentation going out to the projector. Yes. Is that still, we're waiting for multi-support to be able to do that sort of thing?
There's probably a two-part answer to that. And the long part answer is, yes, we don't really have multi-monitor support in the sense that I've used it when, I've had my laptop and I will show the laptop on the overhead projector, and then the screen of the laptop has the reminder notes, which I think is what you're saying.
Yeah.
Obviously, if you ought to do a quick plug for Titanium, Titanium is one of the computers that has two
dual
video
monitor,
heads.
so it had the possibility of.
So yes, the way that you would arrange that is to have a desktop that is twice as wide as the thing that you're showing on the projector.
Yeah.
So then the overhead projector would have one of the heads.
Yes.
And then your local monitor would have your notes.
Yes.
But that is not nicely done in the sense that with PowerPoint, you double click on something and
off it goes.
Figure it all out. You would have to arrange.
Yeah.
You would have to arrange your notes.
So I don't know whether you know anywhere along the way about this one. One of the slight disappointments of having the original Pinebook is as an HDMI. Of course, we can't currently use it. So whether that's something that's being looked at for Pinebook Pro, that would be an argument. Of if you do have an extra socket, then the notes can be on the local screen.
Exactly.
And the presentation coming out of the HDMI.
Yes.
That would be the nice thing.
And that could even be as crude as you have a second copy of TextEase running with your notes. It's like, you run 3 copies of TextEase if you want.
Yeah.
So yes, the one that's I would arrange for the one with the slides to be on one head. And the one with your notes on the other head. Often what you find with system on chips is they're very asymmetrical. So the chip designers don't think, well, you want 2 video heads. Well, we'll just copy and paste that thing twice. That would be the sensible thing to do. What they actually do is they integrate one block from one manufacturer and then one totally different block from another manufacturer. And that's where we trip up in RISC-OS, because we've written one video driver and now we need another totally alien chipset that we need a driver for as well. And sometimes just because of the mix, if it was, for example, on the Raspberry Pi, for example, it's originally targeted at being a mobile phone chipset.
Yes,
So often the graphics chipsets are secret in some way. You
Right.
don't get direct access to the frame store. You have to
Right.
pay a few £100,000
'Cause,
to get
I
an
know-
NDA. And
donkeys years ago, I actually got a phone which had a composite video out. So you can actually use it as a test thing. So you could, if you wanted to show your slides on tellies of the day,
Yeah.
that was about 10 years ago.
Yeah.
And at one point, I know Windows phones, which have never been a big market share one, they were looking at, yes, it is your computer replacement, and you can stick the HDMI up the bottom and off you go.
yes,
And
yeah.
they stopped doing that. And I think all the ones, I think you can now cast from iPods, sorry, what's it? Missing all my words today, aren't we? Apple computers, Apple phones, and also from Android stuff.
Yeah.
So it's still not the same. As I say, I could have, well, on a laptop, and as you were saying, for your desktop as well, you've got the two separate ones that can be addressed separately and effectively have different programs running on them.
Yeah.
Although for the PowerPoint sort of thing, it's just an extension of the program you've got. You've got the notes.
Yes.
Normally we'll look at the notes,
Also to be in sync
and you've
with
seen the little,
slide.
it's got a small version of the presentation at the side along with all your words on.
Yeah.
So that would be the ideal, obviously, but it's a matter of graphics drivers and things like
Yeah.
that. Unless, of course, you want to tout your titanium as the ideal presentation thing,
Well,
other than
yeah,
it's a bit bigger to stick in your pocket.
Yes, it does fit in a rucksack, but yeah, it's
Because I mean, a dual head pipe would be spot on for that, wouldn't it?
exactly, yes,
Yeah.
yeah.
It's just well, if you've got a little battery power supply for it, a mouse and a keyboard,
Yeah.
plug it into two things.
And I think the iJet 5
Right.
has similar.
It's got that
the hardware.
capability,
The
yeah.
hardware has two heads,
Yes.
but one of the heads is driven by a chipset, which is a secret chipset, and so you can't get a data sheet for it. So you can't like drive
They don't you?
So I think
But how long's iGet 5 been out? I mean, there's secret and there's pointless, isn't there?
Yes.
Really? It's so secret. Unless you have £5 million, you can't access it. So who's got £5 million? The mobile phone manufacturer, isn't it? So yeah, it's all a bit bonkers, really, isn't it? Yeah, because of course in the good old days, I know I used to do video editing in a previous job, and dual head for just PAL was the sort of thing you wanted. So it wasn't a big graphics card at all in memory terms, but it had two heads, and you could put different things into them and show them on different monitors. So
you see the clips that you are currently running, and then it spins up the one that you're about to edit into.
that's the sort of thing. Yeah. So I mean, effectively in graphics terms, as long as it does HDMI twice, that's fine, and it doesn't have to do it at movie thing for most people.
Yes.
And I can't remember, does the Pi 4 only do either 4K or 2x1920s?
I think I think it's ultimately memory bandwidth limited. So yes, I think it's 4K at a sensible frame rate.
Yes.
Or, half the resolution, and keep the frame rate the same.
Yeah.
Unless you've got a monitor that can sync down at about 15 hertz.
Well, this is a silly thing. I know once upon a time there were some bonkers modes. I can't remember which computer it was. It's probably a Panda board or something prior to that.
Boards,
And they were down to 30 to 20 hertz.
yes, you could.
Who's got a monitor that shows that? Oh, they're bonkers.
A lot of it out of a Beagle board if you dial down the frame rate.
Yeah.
If you're prepared to dial down the frame rate. Yeah.
Although, of course, bonkersly, some of the modern TVs, for that cinematic look, refresh at 25.
Oh.
Or 24 if they're being very keen.
Still the extra flicker.
Yeah, that's right. Yeah. The flicker you haven't noticed you'd missed because you haven't seen it for 10 years. Any other questions, anybody? I must admit, one of the things that always impresses me, anyone that works for WROCC always seems to have more than two hats. I don't know how many you consider yourself for, because you actually designed the titanium, didn't you?
Yes, yeah.
So is that due for an update then, bearing in mind how the world is going and what have you?
Yeah, I'm pleasantly surprised, and I suppose at the time it was always intended to be pitched far enough in the future that it would buy yourself some time.
Yeah.
And I know that, for example, if I think of things that I was expecting that RISC OS might catch up with dual monitor would be one.
Yeah.
Multi-core processing. So we're still working towards those. So in that respect, the titanium does still hold its own. It's still, I think it's still got the fastest disk interface of any board. I think the Pi 4's RAM, I think, is now overtaken it. So I've lost that crown.
Yeah.
The Pi 3, it's faster than the Pi 3, but I think the Pi 4's RAM.
Yeah, I mean, I did a simple, just because I do that sort of thing, non-technical test of how long does it take for a JPEG to be done on Change FSI?
Yeah.
So that says you're using the OS and how much grunt is it behind it. And the other is some big artworks files I found, which I think on some things, like a RISC-PC 700 will be tens of minutes.
Yes,
And now, of course, they're down to like 6 seconds or something bonkers.
Definitely where
But that's the graphics to some extent, or is it the interpolation on some of them? Because I know somebody had multiple sort of overlays to get a blend of something.
yes,
So I mean, it's checking the graphics to some extent, but it's also the memory.
Sports car, and that's made up of lots of shrinking size sports cars in order to
I'm
get
trying to think.
on it right.
There's actually, I'm trying to think, there's 3 different ones. There's, and I think it's in the standard,
On the Apple.
and not the Apple, because it's just too quick. Well, I think a Raspberry Pi does that in less than a second.
Yeah.
And that's a Pi 3, not a 4. I think there's a lady's face. There's a snow scene, and there's an outer space thing. I can't remember what the names of those are, unfortunately, but they're sort of like test things that I've done to play spot the difference on computers that I've got.
There's a lot of skill in getting a test, or I suppose coming up with a test which is fair. Is quite hard.
Well,
hard
I think
to do
the programmers, it seems to be how long does it take to build a ROM?
Yes.
That seems to be the one that will check out most
That's
bits.
probably the thing that I do most often. So
And strangely,
That I can
us
do it in-
not.
that I can do it in 4.5 minutes.
Yeah.
Is a great, from totally clean, checked out sources is very useful to me, not
Yes.
very useful to most people.
Well, that's it. That's why I was looking at the graphics thing, because it's how long does it take for a big artworks thing to load? And once upon a time would be, let's go and make a brew, and now it's sort of like,
There are different aspects to each of the tests in that you mentioned Change FSI.
Yes.
So that's doing a lot of reading and writing to the memory and going through the processor, because each of the pixels gets visited many times.
Right. The other reason I
Some
was,
people say, Change FSI is slow at displaying JPEGs.
Yes.
Actually, it's not that it's displaying a JPEG, it's that it's doing image manipulation on the JPEG first. You just
That's
want to
right.
look at it,
Yeah.
load the JPEG into Draw. All Draw does is just display the JPEG.
right.
So
Yeah.
the Change FSI, yes, it is slower at loading JPEGs, but that's because it's doing dithering.
But it's sort of
resizing
like
of
a constant in an ever-changing world. It may not be the thing you use, but it's a relative thing throughout time, isn't it? So it says, this is, I think I said, let's have a look at 800 by 600. And now, of course, you might be doing it in full HD
Yes.
in 16 million colors, and it's still taking a lot less time,
Yeah.
so at least, things are moving on that way.
And there are some other tricks as well, where if the graphics driver has acceleration in it. So
Right.
some of the
I think,
Stuff
is it
like
Adrian? Is it Adrian Lee's?
dragging windows around
Yeah.
is the one that exercises that, because that's not replotting the desktop all the time. It's moving a rectangle and then only colouring in the bits around the corner that you've revealed, if you see what I mean. So
Because I think the thing I found with these big artworks files, if you then try and drag windows across them, how long it takes to redraw the artworks file.
yes,
Now, which bit of what that's testing? And I
Yes.
know,
dragging the window is testing the acceleration, but
Right.
the filling back in of the artworks file is all done through the processor. There's no
Right.
acceleration of that.
so I don't know if you probably are aware of Adrian Lee's stuff. He's got Geminus.
Yes, the Geminus.
Now, would that speed up that redrawing of the artworks in the background?
I think he might use extra RAM to cache images.
Right.
So it wouldn't in itself make the plotting faster. That's bound by
No.
the RAM and the processor. But I think one of Geminus's policies is to set aside a load of RAM for caching the contents of Windows.
Right.
So I think it would help you in that sense.
Yeah.
But not in the rendering. Not in the first rendering will still be the same speed as ever.
Yeah, as you say, it's always a catch up. How much of what do you do makes a difference in the speed? So, I mean, if you're a database user, no doubt some things will just go tons faster, but you have to use the same database on everything, don't you? So then know as it got faster.
Take postcodes. Yeah.
Just type Wakefield in.
Yeah.
Right, yeah, I know one of the new benchmarks is how fast does a risk OS map
Yeah.
draw.
If I zoomed out to that one. I'm confused with, because yes, get there again.
We're in Sandal, aren't we? Somewhere?
Yes.
Thorns Park, that sounds familiar. Somewhere around here. So, yes, this is rendering all through the processor. So I don't think there's any hardware acceleration when RISC-OS draws a map. But people like seeing RISC-OS drawing things.
What's the real thing where we sort of win is if we don't make big programs, they run quickly.
Yeah, very true. Yeah, I think TextEase is about 800K or something.
800K. I know it's bonkersly small. I think my favourite one was admittedly used hardware for it. It was Earlham Instruments video editing thing.
Video desk. Yes.
Video desk. And I think originally it came on 3 floppies.
Yes.
Okay, we've got some hardware doing some stuff, but when you look at all the PC ones, even if they were hardware accelerated, it'd be sort of like installation of many hundreds of megabytes.
I don't remember,
3 floppies.
That's for sure. Yeah.
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 Right. Anybody else for anything else?
Questions?
Not any Riff?
Questions online?
Questions online. Let's have a look.
Question about the audio crashes on RISC PC on Raspberry Pi 4. Will it be solved with the next version?
All right. I think it's a TextEase question. It says question about the audio crashes on RISC Pi 4. Will it be solved with the next version of TextEase?
Is that by any chance from David?
Maybe.
David Fugi. I can never say his name properly. It's Fugi.
Yeah. So David has a ticket open, and I have investigated this as far as finding that it's stuck in RISC-OS, it's stuck in the Broadcom sound driver. It's
right.
It's not a TextEase thing. TextEase just sends the TextEase is sending the sound samples out to the OS. So there's something odd about the Raspberry Pi. So no, I guess the short answer is there's nothing special that version 6 will do to change that. The underlying problem is in the Broadcom sound driver somewhere.
Okay. Right, so let's see if there's anything else. I think that's at the bottom of it, isn't it now, Ruth? Yes, someone was saying, what about another different way of doing things? 2 Pi is driven by the same clicker for your presentation, and theoretically, yes. But you could easily get horribly out of sync. I do realise that one.
I think the clicker has, I don't think the RF is just general broadcasting wirelessly. I think
it's paired, isn't it? That's the catch.
I think it has an ID number of some sort in it. I've got a box of these, and I've never found.
Oh, this is interesting.
Found them to talk to each other.
They don't. No, I can tell you because we used to get when I was working at Leeds. As I say, I used to work with PowerPoint and the lecturers, and they say, "I've got my thing, but I can't find the receiver for it." I said, another 127 before you do, I think it is. I think we have something like, it's past 64 frequencies, even from the same manufacturer of pairings. Yes. So if you're really unlucky, it's 127.
Yes. Yeah.
I think the answer is paint it with the colour that makes sense to you. Yeah.
I've certainly, of all the ones.
It's just a USB plug-in, isn't it? Basically.
It's just a little widget thing that's sits in one of the sockets at the back.
We can zoom in eventually, he said. absolutely eeny weeny, isn't it? And this is why they keep getting left in lecterns.
Yeah,
Because you
yeah,
put that in we had
there-
a couple of sockets on the lectern,
It's a
3
handy
memory
little
stick. Yeah,
place to stow it in the back. So
That's right, yeah.
I've been really careful to not leave it in a. I nearly set off without it today.
too
So
easy.
you have
Yeah,
to remember to stow it in a little holder
Yeah.
in the back of the clicker.
yeah.
Yeah.
But those are only about £30 for the basic one.
Yes, yeah, exactly. Anything between sort of 10 and £30 is the
Yeah.
They're not too big.
Yeah, I think CGA used to do them for OHP.
Right. Yes.
I
yeah.
think they didn't originally have that facility. I can't remember what the key presses are for backwards, forwards, left, right, whatever.
Yes, they've all
But,
standardised
yeah,
on what
they're
Microsoft said.
standardised,
Yeah.
So there is a good point to having a Microsoft standard.
Yes.
That might be the only good point.
It makes the clickers to follow PowerPoint.
Yeah. Okay. Well, if we've got no more questions from the audience, and we'll just see. Let's have a look.
There is.
All right,
there
here we
is-
are. Yeah.
There is another question on the chat. Have you any other abandoned software you might be bringing back to life or support?
Oh, okay. So there are always projects on the boil. Definitely, yes. So there's one piece of software that I think it's met the technical possibility goal, but the lawyers have been sitting on it for 14 months. So I've kind of
Can you tell us the area it might cover?
yeah.
No. Yeah, NDAs all over the
Yeah.
place.
So
No.
I was hoping it looked like it was really positive movement in about March this year, but it's just stalled again over summer. So yeah, so there's one software package that I'm very hopeful, as long as the lawyers actually do the thing and send the form to sign,
Right.
that will be available pretty quickly. And then there's some hardware that I've been nibbling at slowly in between. That's still at the PCB layout stage. So
That's not a new computer though. It's something
not a whole
smaller.
new computer. No, I'm hoping to finish that over Christmas.
Oh, right. So
that-
there is a.
the PCB is small enough that
Yeah.
it should be an over Christmas task.
So are you looking at a titanium 2 at some point then?
So I keep an eye on the chipsets available.
Yes.
There is a slightly faster version of the chipset that's used in this.
'Cause it's-
Annoyingly for me, they've changed the pin out though. So I was hoping it was going to be a drop-in replacement.
So is
but-
it, somebody said it's originally an in-car infotainment system main board, which will guarantee the long life. So
Yes,
it's
so the
a new iteration of that. You're looking at.
AM5728 is actually an automotive chip.
Yeah.
Intended for in-car. and
Can you
so
now sell titaniums to car manufacturers?
The oddest titanium that I think I've
Because they're running short at the moment.
went to a nuclear power plant somewhere in France. So
Right.
I'm not sure be
Ah.
afraid about that, but somewhere in France there's a
Well-
titanium running there, one of their power stations. It was all very cloak and mystery. There was one company placed the order
Yeah.
and they said, "Oh, but don't send it to us. Send it
Yeah.
to this power plant
Yeah.
over here." Okay then. So,
It's when they go through a shell company in the Caymans, you always get slightly suspicious.
so,
A number
yeah.
of times that's not happened to me.
I ought to plot on a map sometime, where the strangest titaniums that they're dotted around the
Yeah.
world from Japan to Iceland and
What sort of jobs have titaniums actually been used in? Servers? Or anything like
so
that?
there's a guy in Germany that uses them he wanted real-time audio, so he was very interested in frame accurate. The audio had to be exactly matching the video for some reason. I
Yes.
never really found out why. So he's using
Yeah.
it with Linux, not with RISC-OS.
Right.
And there's a special mode, so the titanium, the main processor chip, has a special mode that you can get nanosecond accurate timestamps for Ethernet packets.
Heck.
So it's really interesting. As whatever this audio was that he was wanting
Yes,
to play back,
yeah.
you needed the nanosecond accurate timestamps to be able to get the audio out at just the right
Because I
time.
know the favourite thing, if depending on your TV and audio system, is out of sync lips.
Yes, they slowly drift out of sync.
That's right,
because
yeah.
The process that's decoding the audio is slightly slower or
It's not
slightly
got a thing to
faster than-
say please catch up. But I think what they call it, QoS, is it quality of
Yeah, the
service?
quality of service, yeah.
Yeah,
So you need to dedicate the same amount of processing power to keep them in sync, otherwise
Yeah.
they drift out of sync.
Yeah.
Or suddenly it will realize that they're out of sync and then it'll freeze the image and let the audio catch up again.
Yeah, yeah.
Yes, that is very annoying. It's surprising how, when I've been editing videos, even just for those videos that were inserted into the presentation.
Yeah.
It's quite noticeable, even if you're just say 2 frames out. So
Oh, yeah.
2/25 of a second, it's really
right.
obviously delayed.
Yeah.
Even though it's such a small amount of time.
Yeah. It's intriguing what our eyes and ears are sensitive to,
Yes.
and
Yeah.
out of syncness is just bonkers. Yeah,
Very
so,
small frame
yeah.
delays.
Right, let's see if we've got any more on the bottom there. That's true. When lip sync goes wrong, just imagine you're watching something that's being dubbed from a foreign film.
Yes.
Yes. Oh, what's
I
it?
was on holiday in France, I guess this was in the 90s, and they had Neighbours episodes there.
Yes.
Obviously, they were a few more months behind than we were, but that didn't matter. And
No.
yeah, they dubbed them into French.
Right.
And that looked very strange because you obviously,
You know what they're
Australian
probably
accent,
saying.
yeah,
Yeah.
you know the
yeah.
Australian accents and how they should
Yeah.
sound, and they got these husky French people.
Yeah.
Oh,
I think it's when
Didn't make
you
any
hear
sense at all.
none of the same voices whatsoever.
Yes,
So I go,
whereas it's
So-
Scott and Charlene.
yeah. it's-
Whereas what
when
I'm
they
used
see
to-
see Kylie Mingo, she's got an Australian accent.
Yes.
That's just wrong.
Didn't make any sense.
Oh, we've got another thing about the TMS sound chips here. Jonathan Harston was saying that you remember on the TMS sound chips that the data bus was numbered backwards. The pin label DO is 1 to 8 and pin label D7 is 1. What a joy.
Good fun. Good
That's
fun.
probably due to the negative power supply, isn't it?
Yeah, yeah, I'll blame that on the PMOS.
I reckon that's where it must be.
Blame that on the PMOS logic. Yeah. Yeah.
Yeah. Righty-ho, I think that's everything from everyone. I've certainly enjoyed the talk. I think everyone else has as well. And as per ever, lots of bits and bobs there.
Yes. If anyone wants to, obviously not on Zoom, but if anyone in the room wants to come and have a prod and a poke at any of the things in person,
Yeah.
I've got.
Okay. Thank you very much. So I don't know if we stop recording and let it go to minor chat now. And there we are.